Hey viewers, welcome back to the channel. Hope you are doing extremely well. So today we are going to discuss another question on the linked list, that is fold a linked list. So here it is, fold a linked list. Okay, so before moving on to the question, if you guys are new to our YouTube channel, then don't forget to subscribe the YouTube channel and hit a like button. So let's discuss the problem statement. Okay, so in this question we are provided with a linked list. Let me write it like 1, 2, 3, 4, 5, 6 and 7, and we need to update this linked list in such a way at 1 start pointing to the 7, 7 start pointing to the 2, 2 start pointing to the 6, 6 start pointing to the 3, 3 start pointing to the 5, and 5 start pointing to the 4. Okay, the other thing about this question is that we need to efficiently update the links, just because other functions like add first and add last have been called to check whether you have efficiently updated the links or not. So I hope you got the question. Just pause this video, try to solve it by yourself, and after that we will discuss its solution approach. So I hope you tried it by yourself. Let's try to understand the problem statement again. We are provided with linked list like 1, 2, 3, 4, 5, 6, 7, and we need to update the links in such a way that first node, that is 1, start pointing to the last node, that is 7, the second node, sorry, the last node start pointing to the second node, that is 2, the second node start pointing to the last second node, that is at 6, the second last node start pointing to the third node, that is at 3, and third node start pointing to the last third node, that is at 5, and fifth node start pointing to the fourth node, and it is null. Okay, let me write the first node start pointing to the last node start pointing to the second start pointing to the last second start pointing to the third start pointing to the last third, and last third start pointing to the fourth. So what will be my approach to solve this problem? My approach will be nothing new. I'm just going to use the same concept which I used in the is palindrome method, is linked list a palindrome or not, and reverse data recursive method. So if you have not watched that video, go and watch that video, just because my 80 to 90% of solution are based on that concept only. So if you have watched it, then you get the solution. So let's try to figure out how this solution will help me to achieve this task. Okay, I know that I am provided with 4, 5, 6 and 7, this linked list. Okay, just focus on what I'm saying. At each time I need to update the node of the first list, the link of the first link of the first node in such a way that it start pointing to the last node. Okay, just forget how the last node get updated, just focus on what I'm saying. So each time we need to update the links in such a way that the first node start pointing to the last node, the second node start pointing to the last second node, the third node start pointing to the last third node, the fourth node start pointing to the last fourth node, and nodes we keep on doing like this. Okay, what if I see the same type of requirement, such type of requirement was also required in the question of is palindrome, just because a string or a list is palindrome only if the first data is same as the last data, the second data is same as the last second data, the third data is same as the last third data, and keep on. Okay, so means my requirement is same. I hope you get it. So what I'm going to do, I'm going to solve this question by using that same concept. Okay, what I'm going to do, at each moment of time, I want two nodes, one node from the very beginning and one node from the extreme, but of the same level. Means if I'm getting the first node, I want the last node. If I'm getting the second node, I want the last second node. If I'm getting the third node, I want the last third node. Okay, so let's try to understand this problem and let's try to solve this question by creating a stack. Okay, I'm going to create a stack and figure it out at how this question gets solved with the is palindrome concept. Okay, so which concept I use in the is palindrome? Okay, is palindrome was based on the reverse data recursive. So what was the intuition behind that question? The intuition was nothing that I'm going to recursively iterate over my linked list unless based on some condition. Okay, because in other question there was some condition, here there is no condition. I'm keep going on recursively iterating over my provided linked list till unless and until I will not encounter the base condition. The moment I encounter the base condition, I do some updations, keep on backtracking, and during the backtracking, I perform a lot of work, and this lot of work will give me my required output. Okay, so let's try to iterate. Okay, let's try to figure out what will be work, how will I iterate. At first, I'm going to iterate over the provided linked list. At first, okay, let me write the address of each node: 1k, 2k, 3k, 4k, 5k, 6k, and 7k. Okay, at first 1k get called, 1k recursively called its next node, that is 2k. 2k recursively calls to its next node, that is 3k. 3k recursively calls to its next node, that is 4k. 4k recursively calls to its next node, that is 5k. 5k calls 6k. 6k calls 7k, and 7k calls to the null. Here I encounter the null condition, and from this null condition I keep on backtracking. From here I'm going to backtrack, and during the backtracking I will perform some tasks. Okay, yeah, we will figure out what will be the task, but before that let's look at some other thing. But I told you earlier that when I reach to the extreme point, I know that with the help of recursion I can easily iterate over the linked list from right hand side to the left hand side, which is not possible using the iteration method. Okay, so means I can iterate over this linked list from the right to the left, but when I reach to that point, I want this point also. Even in the is palindrome method, I want both of these nodes now, so that I can compare both of the data. So to update the links, I want both of the nodes. So what I'm going to do, I will create a new variable that will be nothing but, let me call it the left, just because it is going to iterate from the left hand side to the right hand side. So let me call it to the left. What I'm going to do, when I reach to the null, I'm going to update it with the head. Okay, the moment I come here, this left is pointing here and this node is pointing here. So let's figure out how it will work according to a requirement. So at the very beginning, when we backtrack from the null condition, this function stack got deleted. Left is already updated with the head, and this 7k condition encounter. Now what is going to happen is we are going to work according to a requirement. We want that the first node, that is left, next, is now not pointing to the 2, it start pointing to the node. Okay, similarly node.next is now not store the value of null, it start pointing to the left.next, that is it start pointing to the value of 2. So what I'm going to do, at first I'm going to update the last, that is I'm going to update my node dot next. Actually it is currently pointing to the null just because it is the last node of the linked list. We know that last node of the linked list is pointing to the null, but I want that no, you don't need to point at the null, you need to point at the left.next. So I'll update it with the left.next. Okay, similar. So this link, sorry, it is pointing to null, this link get breaked and it start pointing to this 2. Okay, now again I want this one, that you are not allowed to point to the 2, you are only allowed to point to this 7. Okay, this 7 is nothing but node, means left.next means you are not allowed to point to this 2, you are only allowed to point to the node, that is 7. So this link get break and this link get established. This one start pointing to the 7. Okay, now again what happened, this function stack got deleted from here. I recursively backtrack. Now I reach to this 6k. Okay, let me remove something from here because it is so much messy. Okay, this link is established. Now what happened, this left get updated, sorry, at first left is pointing here. Now the function stack at the top of the stack get deleted as I return from the function. This node is now not pointing to the 7, it start pointing to the 6. So right now it start pointing to the 6. But here you can see that for the 6, I want left to point to the 2. But currently it is pointing to the 1. I need to update the left. So how will I update the left so that it start pointing to the 2? Means currently who is pointing to the 2? So if I can say that my node.next means before the destruction of the function stack, my node was pointing to the 7 and its next was pointing to the 2. So what if I will update the left with the node dot next? If I update the node and the left with this, what happened? My left start pointing to the it was 1k, start pointing to the to here. Now again I perform the same task. What I'll do, I will tell the 6k that no, you are not required, you are not allowed even to point to the 7. You are only allowed to point to the left dot next. That is, you are only allowed to point to the 3. Sorry, here you are only allowed to point to this 3, to point to this 3. Similarly, I will order this 2, it order to this left, that no, you are not allowed to point to this 3, you are only allowed to point to this 6. Okay, so this link get break, it start pointing to the 6. Okay, I hope you get it. Let me remove something from here. This link get break. As this link get break, this link also get break. Okay, again I will update my node. As the function stack got deleted, the node already get updated, but before updating the node, means before destruction of the function stack, I need to update the left. And how will I update the left? My left get updated by the node.next. Means currently node.next is nothing but 3. So, and earlier my left was a 2, so my left get updated with this 3. Okay, now function stack got deleted, my node is again not pointing to here, my node gets start pointing to this 5, start pointing to this 5. Node is at here. Again, what I will do, I will order this 5 that no, you are not allowed to point this 6. How can you point to the 6? You are only allowed to point to the left dot next, that is this 4, and I will order this 3, order the left, that how can you point to the 4? You are only allowed to point to the node. So means your left dot next only contain the node. So this link also get break, and this 3 start pointing to this 5. So at last you can see here is the cycle, that 4 is pointing to 5, 5 is pointing to 4, 4 is pointing to 5, 5 is pointing to 4. If we don't make any one node to point to the null, then this keep on going and going, and it will create an infinite loop. Okay, means we need to break this loop and make some node to point to the null. And as you can see, as per a requirement, 1 2 3 means okay. So as per the requirement, like 1 was pointing to 7, 7 was pointing to 2, 2 was pointing to 6, 6 was pointing to 3, 3 was pointing to 5, 5 was pointing to 4, and 4 was the last node. So means always last node point to the null, so it will point to the, it was pointing to the null. It was as per our requirement. So I will explain you this last case again, but let's try to code till now what we have written. Okay, let's move on to the compiler. K-fold, what we are going to do, at first we create a new variable, that is static node left. Okay, I will create a helper function, that is fold helper. I will pass this dot head to that function. Let me create this function, public static boolean. You might be thinking that why I am returning the boolean I will explain you a little later. Just wait for some time. Okay. Old helper, ELP helper, and it is taking node dot node as a parameter. Within this function, I'm keep on recursively iterating over my linked list. So what I'm going to do, I'm calling this function old helper again and again to the node dot next. The moment, so there will be a moment when I reach to the base condition. Let me write the base condition. If base condition arrives, base condition will be nothing but node reaches to the null. I'll do, I will update the left with the head, this dot head. Okay, and I will return true from that case. Okay, so here you can see one more thing. The thing was updating the links. How we were updating the links? So updating the links was, our steps was node dot left at first point to the left dot next. Okay, and left dot next get updated with node. Now as I have created the link, I need to update the left. Okay, I'll update left with node dot left, and there are some more modifications which need to do in this thing, in this code. We will figure it out a little later. Before that, let's try to understand some base cases. Okay, assuming that we are provided with 1 2 3 4 5 6 this linked list, and 1 2 3 4 5 6 and 7 this is even linked list. As you can see that there are even number of nodes. This is odd linked list as there are odd number of nodes. So what happened that it get updated in such a way that once start pointing to 6, this link get created. Okay, let me update the links with the yellow color. 1 start pointing to 6. Okay, 6 start pointing to 2, means from this point, at the very initial state, my left was here and my node was here. I update these links. Now my node left was here, my node reaches to here. So I update these links. 5 start pointing to 3, my 3 start pointing to 4. Again, my left reaches here, my node reaches here when this updation arrives. Okay, so wait, you can see here left. Okay, you can see here that now I don't want any more requirements. I just need to update any one of the node with the null, just because if I don't update any of the null, either of the left or either of the node, which node get updated, we will figure it out a little just after some time. Just sometime telling right now that now I don't want any more nodes, just because I have achieved my requirement. Now what I want is, I want to break this link and make one of the node to point to the null, and this node will be nothing but any node, because here left and right, just because as it is even, my left is 3 and my right is 4, I want this 4, that node dot next, to point to the null, just because it will be my final node dot next to point to the null. So because if I don't update my fourth node with a null, then it will create a loop and it's keep on going and going, and it will get to an infinite loop. Now let's discuss this case. At very first, left was here, node was here. I create a link like this. Okay, or during that time, let me remove it. Okay, and let me take it upward. Okay, so you can see left was here, here was left was here, node was here, and I created a link like this and updated the link like this. Now again, my left get updated and node get updated in such a way that my left pointing to the 2 and node pointing to the here, Similarly, I'm updated the links in such a way that it starts pointing in like this. These links are already broken up. Okay. Now what I'll do, I will again update the left and the node in such a way that it start pointing here, it start pointing here. Node, sorry, the node, the left will get start pointing to the 3 as I am marking it to the 4. It was my mistake. Okay. 3 start pointing on left start pointing to the 3 and 5 start pointing to the nodes start pointing to the 5. So here I will update the links like this. Now again you can see that my left and node start pointing to the same point, that is nothing but 4. Okay, here let me remove them. These start pointing to node here and left here. The moment I come here, now I just want, you can see here that a cycle has been made here because 5 is pointing to 4, 4 is pointing to 5, 5 is pointing to 4, it is pointing like this. Okay, okay, you can see like pointing like this. 4 is pointing to 5, 5 is pointing to 4, 4 is pointing to 5, 5 is pointing to 4. What I want right now is that I don't want this loop, I just want this 4 to point to the null. Okay, so there are two base conditions that come arises. What I will do whenever my node and left reaches to the same point, I don't want any updation, I just want my any of the nodes start pointing to the null so that I break the loop that has been made in the linked list. Similarly, when my node when my left dot next become equals to the node, then I want to break that loop so that my linked list will not get into the infinite loop. Let me write that code. So as I told you that why I am passing here the boolean variable. The boolean variable I am passing here just to tell that whether this is the point where do I need to update the links or not. Like here you can see if false means if I am getting false from the fold header dot next means here I am just returning, I'm not working, means from here you can see when I update the node dot next or when the moment I pointed some of the node to the null, from here I keep on returning the null, sorry not null, false, just because my recursion, my backtracking keep on iterating this node also, this node also, this node also, because here also if I'm going to make changes then it will not make my output as per the requirement. Okay, that's why I'm returning false and true as per our requirement. If I'm returning true means if I get true from the during the recursion, that means I right now this is the node on which I can make updations. But if I get false from the during the recursion, then I can see that no, I have made all my updations. I have updated that node which is pointing to the null currently. So right now I just no need to perform anything, I just need to backtrack. Okay, so here I'm checking if I'm getting false from the false during the recursion, then do nothing, just do nothing, just recursive, just backtrack. And I'm checking two base condition. If my node become equals to the left, this is the case of even node, sorry, this is the case of odd node, sorry, this is the case of odd nodes. If this case arises, what I need to do is I just update the left dot next with, I will make left dot next point to the null, I will make tail to the left and return false, means after that like I have made all my updations, now don't do anything, just return false, means after that I don't want any updations, I have made my final updation, I want the final updation, I don't want any final updations, I have made all. During the backtracking, do nothing, just backtrack. Okay, similarly I will do if for the case of even, if left dot next, left dot next will become equal to the node. If this case arises, means this is the case of odd linked list. Sorry, even nodes. This is the case of even nodes. So in that case, what I'm going to do, I will do node dot next equals to null. Okay, and update the tail with a node, and here also I will return false. Here also I need to return the true, just because here I'm making updations, and I need to tell that I have made my updations. During the backtracking, you will make your updations. Okay, so each node is telling to its peer node that I have made my updations. You will make your updations during the returning. Okay, so I think that's all for this code. So let's try to run it. So we get a compilation error, return false. We have not. So here we forget the semicolon. Let's try to compilation left equals to this dot head non-static variable. This cannot be referenced from a static context. Okay, means we have made our function static. Okay, we just forget it. Let's try to submit it again. Node dot left cannot find symbol. Okay, it is saying that node dot left, there is no left, there is next. Actually, it was my mistake or typo mistake. So it was not left, it was next. Node dot next get updated with the left dot next. Again compilation error, left dot next. Here also the typo, left dot next, that was not left, that was next. You can see it is accepted. Let's try to submit it for all the test cases. So yeah, we got the answer. So I hope you get it, that why we are handling two cases, one for the number when the number of nodes in the linked list are even, one when the number of nodes in the linked list are odd. We are using the same intuition that we used in the is a linked list palindrome. So the intuition was nothing, that keep on iterating over the linked list during the back propagation, keep on working as per our requirement. So here also we are doing nothing. Each time we just updating the links, we keep on iterating the left pointer from left to right, and we know that using the recursion we can easily iterate over the linked list from right to left. I hope you get the solution. If you like this video, don't forget to subscribe our YouTube channel, hit the like button, and share it with your friends. So till then, stay safe, stay healthy.